the generation of electrophile. See, any alkylating agent that you have in your syllabus to study, if you see the structure of that alkylating agent, that structure is very simple. Okay, that structure is very simple, and here you will have R. So of course these R will be different, but this particular part you will observe which is common in all the alkylating groups. And this part is something which is important for our mechanism point of view. Okay, so this is my alkylating agent. So it could be a phosphamide, it could be a chlorambucil, it could be melphalan, any of it. Only the R group would be different. Some kind of a left-hand side of the structure would be different, and right-hand side is most appropriately similar to this. My electrophile generation is with this square box. Okay, my electrophile generation is taking place with this square box, meaning my electrophile generation is taking place with the common part of the structure, and how that is done, that we will see now. Okay, so now if you just focus on this particular structure which I have written in the square box, you have a chlorine being present there, right? You have NCH2CH2Cl. So what happens from this? Ultimately, you have to generate your electrophile. If I have to just go behind, and if I have to just give the analogy we have discussed yesterday, when you talk about the alkylation of benzene, you have CH3Cl reacting with AlCl3, it gives you CH3 plus and it gives you AlCl4 minus, and then this is your electrophile which attacks your benzene, and the entire reaction you get. So what I need basically, I need to generate the electrophile, right? So from where I'm generating this electrophile I will be generating from this particular square box. How? For that, just pay attention here. You all know that chlorine is having a lot of electronegativity. I mean, it is very, as far as the electronegativity potential is concerned, chlorine is the best one, right? So what chlorine will do? Chlorine will try to pull the electron cloud. Is it possible? Yes, it is very much possible, because nitrogen is with the lone pair of electron, and of course chlorine being the negative, it will try to pull that electron cloud towards itself. In that particular thing, what will happen when chlorine is pulling the electron towards itself? Naturally, this particular CH2 unit would be partially delta negative, right? It will be partially delta negative. So when this particular carbon is partially delta negative, the lone pair of electrons on the nitrogen will attack on this particular carbon. I'm rewriting this structure little bigger enough so that it will be easy for everyone to see. I have this particular thing. I have said that chlorine is electron withdrawing group. Chlorine is having your electronegativity very high, so it will try to pull the electron towards itself. From where it will pull the electrons? It will ultimately pull the electrons through this aliphatic chain, and because of this particular carbon which is immediate to your chlorine attached would be delta negative. Sorry, it would be delta positive. Okay, it would be delta positive क्योंकि इससे electron cloud is shifting towards the chlorine. So this carbon is your delta positive. Since this particular carbon is delta positive, the lone pair of nitrogen will attack this delta positive center, and what it will generate? Can anyone tell me what it will generate? What the structure, how the structure would look like?
Carbocation.
Yes. You have this chlorine getting departed. Okay, you have the chlorine getting departed, and then this particular carbon is delta positive, because of which the lone pair of electrons on the nitrogen will attack here, and then you will have a structure where this particular unit will remain as it is, and you have this particular kind of positive charge being generated. Are you able to see the annotations on slide? Everyone?
Yes, ma'am.
Yes, ma'am.
So this is what the positive charge is getting generated. Now, is it comparable to the electrophile? Yes. Is it comparable to the electrophile? Very much, because your electrophile is positively charged species, right? So when you are considering this alkylating agent, those alkylating agents are intrinsically so active, they are so much active that because of the presence of Cl, it will try to pull the electron and it will try to depart, taking that electron cloud towards itself, making the adjacent carbon with the positive charge center, and thus the nucleophile of the nitrogen will attack that particular carbon and will create this cyclopropane. I mean the three membered, I should not say cyclopropane, but the three membered kind of ring. This particular ring, now if I just review it from chemistry point of view, it is absolutely similar in the capacity of electrophile, right? So I will always get my anti-cancer drug, I will always get my electrophile being obtained from the alkylating agent. I will always have an electrophile. I have a nucleophile which is in the form of guanine. Okay, why guanine or why all other nucleophilic bases will act as a nucleophile? We have made a very broad statement, right? All nucleophilic bases would be your nucleophile, and yes, precisely guanine we are currently focusing upon. But then why all of them would be nucleophile? Because all of them have got the nitrogen species, they have got many scope for they have double bonds, so there is a scope of resonance, and ultimately if you just focus on the structure, you also yourself will get convinced that the structure is nothing but the nucleophilic in nature. Because ultimately what you need when you say nucleophilic nature means the structure has to be electron rich, right? The structure has to be, the species has to be electron rich. So you have electrophile being generated from the anti-cancer agent, you have your guanine which is acting as a nucleophilic in nature, so the reaction will take place between the two, and what you will have as a product is guanine which is alkylated with this electrophile, right? The guanine which is alkylated with this electrophile. So I have a structure of guanine, I'm just writing the I mean, this is your 5-membered ring. I'm just writing that. I'm not going into the further detail. This is your, let's say, a purine ring nucleus that you will have. And on your N7 position, you will have this electrophile being present, right? You will have this electrophile being present. So how exactly this particular bond formation is taking place now? Okay, how exactly this bond formation is being formed so that you will get an alkylated guanine? You have this particular reactive intermediate being generated or reactive electrophile being generated. Now this will react on the guanine structure. Guanine being the nucleophilic in nature, having the negative charge on it, this particular negative charge will attack here, and this particular ring would get open up, right? And this particular ring would get open up. So when this ring is opening, what you have is you have R, you have nitrogen, the rest of the side is same as it is. Okay, this ring is getting open, and what you have now is guanine. So can I say that the guanine is alkylated guanine now? Can I say that the guanine has got alkylated because of my alkylating agent? Yes. So this is the basic feature of your alkylating agent. Each and every alkylating agent will ultimately going to alkylate your guanine. Okay, now if I will just focus on this particular part that I have written here, I have just considered one side of my alkylating agent, I have just considered one side of my drug, and I have alkylated the guanine. Similar kind of sequence would also happen with the other side chain of my alkylating drug, right? And then what do I will get in that case is I will have in that case my guanine being getting alkylated at both the ends, and that is precisely what we consider it as dialkylated guanine. This is monoalkylated guanine, this is your dialkylated guanine.